All right, day 171. Looking at magnetism, also a little bit of circuits practice. For your warm up, we got a resistor, a switch, a battery, all in series, and you need to draw them. And then find the current through them. So go ahead and do that now. Okay, how do you do this? Right here. So we've got our battery. I've labeled it 12 volts. We've got our switch and our resistor. It's 5 ohms. And to find the current, it's voltage divided by resistance. 12 divided by 5, 2. Probably kind of hard to see. 2.4. Okay. Don't forget textbook return.
Give me some jelly beans.
I know you hear me talking, but you can have jelly beans after lunch.
No, I eat jelly. We eat snacks quickly before lunch.
I don't think so. I love you though. Okay. All right, let me finish my video.
And then can I have some jelly beans?
Sure.
Yay! Let me put some popcorn so
You want the popcorn ones?
Yeah. Because I want to give some popcorn to Jackson.
Yeah, he likes them too.
Jackson, I'm going to give you
Okay.
some jelly beans.
So we're doing an activity called Thinking About Magnetism. The link is here, and you can pull it up right here. Oh, oops. Hey. All right. So think about some things that can and cannot be picked up by a magnet. Okay. So I want you to try and go through this as best you can. This is just it's kind of an intro activity for magnetism, where you just kind of think about what you know and what your educated guesses are for how magnets work. Right? Like what makes a magnet stick to a fridge. What is doing the attracting? Is it a magnet attracting a nail or a nail attracting the magnet? Like what's going on there? So read through here, give your best answers that you can. What you think it looks like inside of something that is not magnetized and something that is magnetized, and then we'll go over it. Okay. Ha! Look, I'm over here. All right. So by now you should have some ideas for what is and is not magnetic. Obviously, things that aren't metal at all aren't magnetic. But what about the metals? There are lots of metals. Like you probably know that you can take. It's the best magnet I have, guys. See this little thing? This came from my toothbrush. It's great. Best magnets. Really strong. So you know that I can take this magnet and I can put it on this aluminum can. It doesn't stick. I can put it on this. This is metal. Nothing. Again, this is a really strong magnet. Oh. Nope. Not gonna do it. What about this? Oh. Okay. What about this guy? Okay. This thing? Definitely. So, why? Well, some of these materials have iron in them and some don't. Some of them are called ferrous and non-ferrous. So ferrous means that there's iron inside, and non-ferrous means there's not iron inside. So, what are some things that are magnetic? Well, we can take a look. I'm going to sit down. So, like all these things that are non-magnetic, you're not listening. Get off the table. Sit down.
But I want to get my pink thing. I have to go get my pink.
Get down.
I was going to get my
That's
pink.
great. So gold, aluminum, silver, these are all non-ferrous. Things that have nickel, cobalt, steel, and iron in them. Those.
I need to write on something.
Go get some paper. Go to the printer and get some paper. Those things all have iron in them, and so they are attracted by magnets and can be magnetic. Let's see. Here it is. I can see Nick. Easy way to remember these things. I for iron, can, the C for cobalt, the S for steel, Nick for nickel. Okay, get paper. Those are all the magnetic things or ferrous materials. Okay, so getting back to our activity here. So if you said that everything that's metal can be picked up by magnets, it's not actually true, but most things can, and anything that has iron in it can.
I want apple juice, Dada.
Ooh, I don't think we have any apple juice. I can give you tangerine juice or orange juice.
I want tangerine juice.
Okay, a little bit. So, well, fork's made of metal. Anything can be picked up by metal. Anything made of metal can be picked up. Yeah, so that's not true, right? Only some things. So why? Well, we just talked about it because some things have iron, and iron is magnetic, and things that don't have iron in them are not. What is it? Unseen force. You can't see it. All right. So there's a magnet in here, and it is magnetized. This Phillips screw bit. This screw right here is not magnetic. I'm going to put another screw in my hand, and I'll show you. They don't care about each other. But watch this. I've now put the same screw on the end of my screwdriver, and there's a magnet in my screwdriver right here. And watch what happens. You probably can't see. Here we go. Watch what happens. Boop. And there you go. All right. So it shows that when you have materials with iron in them, you can magnetize them. What's that about? We'll get to that in a minute. What if you wrapped a magnet with aluminum foil? What would happen then? I forgot to get my foil. I'll be right back. Okay, I'm back. And I've taken the screw and wrapped it in aluminum foil. We got our little baby magnet here. I can put this anywhere on here. Still very attractive. The field is able to pass through the aluminum. The aluminum itself is not what's sticking to the magnet. The magnet is attracting the iron inside the screw, and that's able to pass through other materials, which is kind of cool. That magnetic fields can do that, pass through stuff. All right. So what does it really look like inside? What's going on? When something's not magnetized, it looks like this, H. Another way you could think about it is kind of like this, F, that you've got all these little pieces of the material, and the iron parts are just all different directions. They're all going different directions.
I need something to cut off this line.
Okay, go find your scissors.
I don't know what this is.
These scissors are in the bucket over there in the art center. Yeah, the art center. So in here, in this little screw, there are, billions, trillions, many little iron. Okay, iron atoms, and they all have electrons, and those electrons are all spinning in different directions. And depending on the direction of spin, there's a little bit of magnetic field that comes out of spinning a charged thing. And when they're all going in different directions, they kind of cancel each other out. But if you can get them all to point in the same direction, like this, and all those little teeny magnetic fields. They're called dipoles, Dipole. When they're all pointing in the same direction, it's like, if you had one person pushing on a boat, it wouldn't really go anywhere. But if you had, say, 1,000 people pushing on a cruise ship and they're all pushing the same direction, eventually it might start to move. So small things can add up to big, protests. Okay. So that's what's going on there. Let me show you some other cool stuff. That's the end of that activity. What's really going on inside? Well, here's some unmagnetized iron, and we have what are called domains in here. And this is what's special about magnetic things. They have domains. Non-magnetic things don't have domains. And so when things are not magnetized, the electrons and their spins are pointing all over. When they are magnetized, they all go the same direction. When they do that, they have a magnetic force that you can see the effects of. What else? Here is a cool thing that you can try.
Daddy, can you erase all of this stuff?
You know what? Did you notice it's kind of hard to erase the crayon?
No, yeah.
Yeah, crayon doesn't erase very well. That's an eraser for pencils. Pencils erase, but crayons, once you draw with them, they usually stay. Okay? So if you want to do something different...
It's a little bit long.
Okay, well, you can either fix it or you can make a new one. Okay? So this is a cool thing that you can do with a battery and a little bit of wire and a nail. And what will happen is when you wrap this around here, it'll generate an electric field. That electric field generates a magnetic field, and that gets put out by this nail. Everything gets ordered in here. All those domains that we saw, they all line up, and you get a magnetic field. This is called an electromagnet, and it'll have a north and a south pole. And if you have wire, a battery, and a nail or a screw or any piece of metal like this that has iron in it, you can make your own electromagnet. And then this would pick stuff up. You could touch this to something and it would pick it up. Even though individually, all by themselves, you touch a battery to something, it doesn't attract it. You touch a nail to something, it doesn't pick it up. You touch some wire to something, it doesn't pick it up. But put all these three things together like this, you make an electromagnet, and you can pick stuff up. And that's how this works. Right here. Electromagnet. There's a generator in there. And cool stuff. So I'll share these materials with you, and you can take a look at them. It talks about the different types of metals and how magnetic they are, and like all these other things that aren't magnetic. What's the deal with that? Copper is sort of magnetic at really high energies. So fun times. Okay, that's it. Final will be up tomorrow. You can take it anytime between then and Tuesday. And I'll see you Monday, 11, for a little Zoom demo, show you how to make a motor.